Istio, a service mesh for microservices. Agenda, service to service communication. Istio history. Why Istio? Traffic management lifecycle. Getting started. Basic workflow. Sidecars and mutual TLS. MTLS. Service to service communication. As an application splits into many microservices, those services need a reliable way to find, call, and secure connections to each other. If a downstream service fails, well-designed communication retries, times out, or fails over instead of cascading the failure everywhere. Almost every microservices architecture usually needs consistent traffic control, security, and observability between services. Any team running dozens of services benefits from handling networking concerns in one consistent place instead of many. Rebuilding retry logic, timeouts, and TLS transport layer security in every single service doesn't scale. Direct service calls and service mesh. Direct service calls mean every service implements its own retries, timeouts, load balancing, and TLS by hand. A service mesh like Istio moves all of that networking logic into a shared layer transparent to the application code. Direct calls, hand-rolled HTTP clients, custom retry libraries, logic duplicated per service. Service mesh, Istio, Linkerd, console. Problems without a service mesh. Single point of failure, inconsistent retry and timeout logic across services lets failures cascade. Every team re-implements the same networking concerns in its own language and style. Encrypting traffic between services means wiring up transport level security TLS certificates by hand, service by service. Hard to see how traffic actually flows between dozens of services without dedicated tracing. Difficult to roll out canary releases or traffic shifting without custom infrastructure. Misses out on centralized policy for security, routing, and observability. The Istio service mesh system. Traffic rules are declared in Kubernetes native YAML resources and kept in the source or Git repository. A lightweight NOI proxy sidecar is injected next to every service instance to intercept its network traffic. Istio's control plane, Istio-D, configures every sidecar and keeps the mesh's actual behavior in sync with the declared rules. Other similar service-based systems, Linkerd, Console Connect, AWS App Mesh. Istio advantages: adds retries, timeouts, circuit breaking without changing a single line of application code, encrypts service-to-service traffic automatically with mutual TLS, enables fine-grained traffic shifting for canary releases and A/B testing, gives deep observability into service traffic through metrics, logs, and distributed tracing, centralizes authorization policy instead of scattering it across every service. Backed by a large open source community and every major Kubernetes platform. Everything is a sidecar, almost. One huge benefit is that in Istio, almost all network traffic passes through a sidecar proxy sitting next to each service. The application never talks to the network directly. The sidecar intercepts every request and response. Because the sidecar is identical everywhere, policy and behavior stay consistent across every language and framework. Upgrading Istio's networking behavior means upgrading the sidecar, not touching any application code. A service can be added to or removed from the mesh without changing how it was written. Virtual services and destination rules. Virtual service defines how requests are routed to a service. Destination rule defines the subnets and policies for a destination. Virtual service.yml. Here, 90% of traffic goes to V1 of a service and 10% goes to the new V2 for a canary rollout. Peer authentication via YAML file. Here, mutual TLS is enforced for every service inside the namespace. History started as a joint project between Google, IBM, and Lyft, and first released in 2017. Built on top of the NY proxy, which Lyft had already created and open sourced for its own microservices. Reached a one release in 2018. Release 1 was released, establishing the sidecar-based service mesh pattern widely used today. Joined the Cloud Native Computing Foundation (CNCF) in 2022 alongside projects like Kubernetes and NOI. Now one of the most widely adopted service mesh implementations for Kubernetes-based microservices. Why Istio? Consistency. The same traffic, security, and observability policy across every service. Security by default. Automatic mutual TLS between services without code changes. Progressive delivery. Fine-grained traffic shifting for canary and blue-green releases. Deep visibility. Metrics, logs, and traces for every request flowing through the mesh. Kubernetes native. Configuration lives alongside the workloads it governs. Backed by a large open source community and the CNCF ecosystem. Cloud Native Computing Foundation ecosystem. The Istio control plane. Istio is the control plane that configures every sidecar proxy in the mesh. Watches the Kubernetes API for virtual services, destination rules, and other Istio resources. Pushes updated configuration to every NOI sidecar automatically with no manual restarts. Never edit a sidecar's configuration directly. Always change it through Istio's own resources. Istio traffic lifecycle. Client calls, request, envoy intercepts, sidecar, route apply rules, service reaches pod. A request leaves the client, is intercepted by the local sidecar, routed according to the mesh's rules, and finally reaches the destination service. Getting started with Istio. This leads us to the three steps that bring a cluster into the mesh. Istio CTL install. Deploy Istio's control plane onto the cluster. kubectl label. Mark a namespace for automatic sidecar injection. Istio analyze. Check the mesh's configuration for common problems. Basic workflow. Applying, routing, and observing. Some call apply, route, and observe. Istio's everyday loop. Declarative. Apply the same YML again, and Istio only changes what's different. Istio proxy status gives an instant snapshot of every sidecar's sync state. Traffic shifting takes effect within seconds of updating a virtual service. Built-in dashboards like Kiali visualize how traffic actually flows through the mesh. Supports many workflows, canary releases, fault injection, zero trust security, blue-green releases. Right? Works the same across any Kubernetes cluster that runs Istio. Any questions? Thank you.